Alright, welcome back and thanks for tuning in again. So we're back with the 354 series 6-cylinder Perkins, which powers the 45 kilowatt Lima generator. We're going to see if we can get this governor working correctly today. So I'll leave a link in the description and maybe a card to check out the playlist so you can kind of get a little bit of background on where we're at with this thing. But basically today I've got some new governor parts. We're going to see if we can get this thing running right. Let's get started. Okay, so here's what we're working with. First off, I'd like to thank two viewers that gave me some good advice and some good information as far as locating this new governor spring here. So first, AJ, thank you very much for recommending a vendor to source the new spring. And then Paul, thank you for sending me the relevant manuals and information for the injection pump itself. First off, we have a chart here for identifying the date when the injection pump was built. If you want to read all that, feel free to pause and take a look at the chart here. Based on this information, if I decode my serial number suffix correctly, WT, I believe my injection pump was made June of 1979. So I would assume the gen set would probably be a 79 or an 80. Secondly, we have some more important information here, which is decoding the code number on the injection pump, which is it's stamped on the tag. Here is my code on the pump, MR72/720/8/1880. So based on the decode here, we know the type of injector nozzles that the pump should be calibrated with. That's not really relevant to me, as well as the maximum fuel setting. Again, not relevant since I don't have a test bench. In this case, 800 was the example. That is the pump RPM for that the pump needs to be run at to calibrate max fuel. Not relevant for me. Mine happens to be 720. The important one for me is code for the spring setting. That would be the governor spring. The example is number 4. I am a number 8. And the last number which is relevant is the no-load maximum engine speed. So, in this case, 3030, but my pump is an 1880, which 1880 RPM comes out to 62.6 hertz. So that's a bit high, a bit higher than I would like. But we'll set it to 62.6 when we do our initial load testing. And as far as that governor spring code, that number 8, we've got a chart here, a table. So for a code number 8, throttle arm hole position 2 and governor arm hole position 3. So this really doesn't help, but we've got a nice picture here. We've got a code number 8. Calls for the lowest hole on the governor arm, so the hole nearest the pump housing, and a throttle arm position of 2. So that's actually where we had it during the last test, 3 and 2. When I initially took the pump apart, it was at 2 and 2. So that was incorrect based upon what the pump nameplate calls for. The new governor spring was recommended by the vendor that I got it from. I sent them the information. The website is dieselinjectionpumps.uk. They were very helpful with this, so I thank them. The spring feels a bit more stiff than the original. You can see certainly it's got a fewer number of coils. The wire diameter is a bit larger as well. This has 12 coils and this has like 19 coils. Like I said, it is a bit more stiff. I also picked up a new idling spring from them. Not that I think there was anything really wrong with the old one, but just figured, you know, for a couple bucks, what the heck, just pick it up. So I'm going to go ahead and assemble the pump, and we'll fire it up. Alright, well, you saw me do this in the last video, and you're going to see me do it again. So we'll pass got my new idling spring there. We'll pass the anchor through the hole nearest the pump housing, hook the spring on that, grab my pair of needle nose, Must have some water in that smudge pot over there. I can hear it boiling away. Oh, don't lose that. Okay. It's a bit difficult with you guys in the way here. No, I can't see. Alright. Let's move you over here. See if we can have some more success now. If my pliers weren't magnetic, I could get a grip on that spring. There we go. Well, that was a bit difficult to watch, huh? Got the system all bled out. Let's fire this thing up and we'll readjust the speed. Well, we're going to let her warm up for a while. We got the no load speed to about 62.6 according to what the injection pump data plate specifies. This is it. This is where we find out if it's going to do it or not. Be back in a few minutes after she's up to temp. Well, the thermostat just opened up, so we are up to operating temperature. We're at 62.5 hertz. Let's put some load on it and see how the governor responds. arguing about that. That governor spring made zero improvement. We still have just a bad amount of governor droop. Well, only thing to do now is to go electronic. Alright, well, it's been a couple weeks since the last clip, and we're going to concentrate now on getting the electronic governor control and governor actuator fitted to this unit. So let's take a look at the components we're going to be using. Let me set you up on the tripod here. So, we've got an actuator and a controller. I've removed the board, we'll go into that in a second, and a speed sensor. All these components here make up essentially a kit that you can purchase on eBay for around $150. Now, all these components are clones of components made by Governors America Corp. Out of Massachusetts. And the reason I took the board out here is just so we can take a look at it, just see what kind of quality we're working with. This is obviously made overseas. I'm not going to lie to you. You know, this kit is $150, which you couldn't even, $150 wouldn't even get you halfway to just the controller if you were to buy it from Governors America in Massachusetts. You know, it's got a pretty nice conformal coating over the board there. I mean, as far as the components, I don't know. That's the manufacturer of that big electrolytic capacitor, Yulu. You know, that's the kind of thing that you're going to have to live with. But, I mean, this is a pretty close clone. I mean, this here, you wouldn't even be able to tell the difference between this enclosure and a genuine Governors America one. They even use the same model, ESD 5500E. That's, I mean, I've used those controllers a lot. And in the industry, if I was going to install this in the field, you know, in a life safety situation, I certainly would not use a clone of the components. They would get genuine parts. But the quality seems there for this kit. Here's the actuator. Let's look at the actuator. You know, it's a cast aluminum body. Got ball bearings on the actuator shaft. I took the screws off the front cover here. So you can see there's not, you know, this is what electronic governor actuator looks like on the inside. If it's not a stepper motor type actuator, it's essentially just this. You've got a coil here on an armature, and then you've got a movable, what would you call that? A movable armature, laminated steel core that is pulled in and out. You know, the harder you energize this coil, the greater the magnetic field strength, the more so it wants to pull this plunger essentially into the field. Oop, just dropped that. Then you've got a stop here, a little nylon stop, and then there's a spring that sits in this pocket here and on around that stop. So something like that. It's a spring return actuator. You know, they're fairly limited travel. The cover is what stops that armature from coming farther out. So you can see that that's all the travel it has when it's assembled. Not a whole lot, but it's enough to do the job. Let me pick that cover up before I lose it. There we go. It comes with the magnetic, the mag pickup, sometimes called a Hall effect sensor. This is unlike, you know, your typical Hall effect sensor, which actually has a switching device in it. All this is a coil of wire with a little magnet in the center. That right there. You can see that picks up a screw there. There's no switching action happening in here. This is just generating an AC signal on the two wires here, blue and red, and then the other is a shield. That's a shield. Blue and red generates an AC signal across there, which the controller analyzes essentially and compares to whatever your set point is. That AC signal is generated by the individual flywheel teeth passing very closely to the tip of that sensor. Let's look at the instructions here. Now this is the strange thing. Pretty nice in the instruction sheet that comes with these. Wiring schematic. You got set up some troubleshooting there. Troubleshooting procedures, methods of adjustment. The odd thing is, I don't know how they get away with this. Declaration of conformity. You see that? And right there, they've got Governors America Corp. Aguam. Not sure how you pronounce that. Massachusetts. So, I don't know if these components are actually made by a company that purchased the licensing to make these components overseas or what, but I'm surprised there hasn't been some kind of suit against this company from GAC. But anyway, enough of that. We're going to use this. I've used these in the past, and they work pretty well. All right, so let's take a look at the engine, what we've had to do to modify this. So we got the throttle shaft on the injection pump. This was the original throttle lever here. Going ahead and remove that. We're left with this like oval-shaped or elongated shaft here. Fits nicely on that elongated hole. We're going to do away with this. And I've gone ahead and I've fabricated a new throttle shaft. We got our elongated hole there, and the orientation is 90 degrees out of phase from what it was originally. So can you see that the throttle shaft in this orientation has the hole in this orientation, and mine is 90 degrees out of phase from that. Just to allow this to line up easier. That'll become more apparent once we get it mounted up. I've got the linkage set up. We got two Heim joints here. They're nice. They got the bronze bearing on them, so very low friction. I've made this bracket here, which has the mounting pad for the actuator. That gets bolted onto this this nicely machined or flat. Sorry about that. This nice flat machined surface here. I've drilled and tapped 1 hole, 2, 3 holes here. They're approximately 5/8 deep. They're threaded 3/8 24. They are blind holes. They do not go into the crankcase. I dropped my bracket here. Okay, that gets bolted on there. The actuator sits on there and controls the throttle. Now, the original mechanical governor is still in play here. And we'll go into that a little bit later once I get everything bolted together. So, let me get that mounted. We'll get everything wired up, and we'll go ahead and install the speed sensor. You know what? Before we do that, there was a nice plug. See this little plug here? It sat in that hole right above the flywheel. So it worked out quite well. I took the plug out, drilled it, threaded it 3/8 24. That's what the mag pickup is. So that was pretty handy. Didn't have to worry about trying to drill directly over the flywheel in the bell housing. So, alright, let me get this assembled and we'll be back in a sec. Alright, now that we've got the governor actuator mounted securely, we'll talk a little bit about setting up the throttle linkage. Now this is the new throttle lever that I've made, and you can see I've drilled 4 separate holes here. I did this because I wasn't sure exactly what relationship I was going to need between the throttle lever on the pump and the actuator lever. You can see the actuator comes with, what, 5 holes here? And it has a pretty limited amount of rotation that's available, and it also has a limited amount of rotational torque. I think this size actuator is only good for about 1 foot-pound of rotational torque. So you have to keep that in mind when you're setting all this up, that depending on what your pump is and how you're connecting to it, you have to know how much rotation you're going to need here and how much force it's going to take to rotate that. You don't want the governor to have to drive the actuator as hard as it can just to maintain a speed. So that's, well, the main reason why I drilled so many holes there is to do just exactly what I said. The farther out the linkage is anchored to the throttle lever, the less force you need because of the lever arm. However, with that less force, you need more linear movement to accomplish the same amount of rotation here. So in my initial experimenting with setting this up, it looks like having the throttle linkage at the lowest point on the actuator and the highest point on the throttle gives me enough rotation on the throttle shaft to respond well to the changing loads without stressing the actuator too far. You see, we only have maybe, if you watch that hole, I don't know, maybe a ½ an inch or so of like travel in the arc of rotation. So that's going to translate to even less at this point here on the throttle, but it should be enough. So let me get this hooked up, and we'll go ahead and pop the mag pickup in, and we'll be ready to start. And I've popped that little plug back in the bell housing. Here's our mag pickup. We're going to go ahead and thread that in. Now when you're putting these in, you need to make sure that you have a flywheel tooth directly under the mag pickup. So you go ahead and you thread that all the way in. Keep going. Thread that all the way in until it hits that tooth. Oh, there it goes. So it's seated on that tooth, and then you back it back out between 1/2 and 3/4 a turn. So we're going to go, that's about half turn right there. You tighten the lock nut up. Let me go a little bit further out, and I'll tighten that jam nut, and that'll be locked in place. So let's go ahead and wire the thing up. Alright, well, we got the governor control temporarily wired up. Just got a toggle switch to turn it on and off, going right to the battery. Got our battery input, magnetic pickup input, and the actuator output. The actuators are not polarity sensitive, by the way, so you just hook them up. Actuator's connected. You see the movement there? Not a whole lot of movement on the throttle shaft, but that should be enough. So right now, I've got the linkage set to give us about, I don't know, about 58 hertz. So with the actuator at the no fuel position, the throttle lever set at about 58 hertz. We're going to adjust the governor up to just over 60 hertz, like 60.1 or so, and we'll go from there. And we'll go through the speed, the gain, and the stability settings. These little dip switches here, right there, 1 and 2. Lead, they call that the lead circuit, and soft coupling, which these are just, I don't know how I can describe this, modifications on the way the governor responds to the changes in the pickup signal. You can read about what soft coupling is and what the lead circuit is if you look up this model here, the ESD 5500E, on the internet. Just pull up the manual for this and read about it. I have found that the best way to set these up is to set the lead circuit off. We don't need that. But to turn the soft coupling on. I usually start with setting both pots to either the middle position for gain and stability, the middle position, or the minimum position. We're going to set these at the minimum. And then the speed pot, which is this little guy here, that's a 25 turn pot. I set that all the way down at 0. So you turn it counterclockwise until you can hear it click. That's nothing. That's 0. Droop, we're not going to use. We're not paralleling. Idle, we're not going to use. And starting fuel and speed ramping are only if you're using the idle function. Which, the idle function, you jump between, I believe, M and N. You jump those for idle. You jump K and L for droop operation, and then G, H, and J, that they would go out to your remote speed adjust pot, which we're not using that either. Just a very simple installation. So I'm going to go ahead, we'll turn the governor on now. I got my meter set up here. We obviously got the load bank connected. So let's start her up.
Okay,
well, I think we're going to try to do a voiceover for this adjustment of the governor part of the video, just so you can clearly understand what I'm trying to say here. So right now we got the engine running. It's at about 58 hertz, 58.2. Now that's with the governor essentially doing nothing. So you can see I'm revving the engine a little bit here. Got full throttle. We're at 68 hertz. Minimum throttle 58. So we got 10 hertz worth of adjustment on the with the governor actuator. That's its maximum amount of adjustment that it can provide to the engine under no load conditions. So let's take a look here at the controller. At this point, we can start ramping the speed up to hit our 60 hertz mark. We're just gonna start dialing up the speed here pretty rapidly. Again, it's 25 turn pot, so it takes quite a few turns to make any difference here. So you'll note that the speed is going to overshoot. We're just sitting here at 58 hertz. We haven't hit the threshold. Oh, here we are. So we're at 68 now. So now I'm turning it down counterclockwise. Now the reason it shot up so rapidly was it's a result of the fact that I have the gain and the stability turned way down, so that the governor is responding very, very sluggishly to my set point adjustments. So we're almost at 60 hertz. This is just, I'm dialing it up a little bit down, a little bit up, to try to get it in the ballpark of 60 hertz. So let's see here. Right. Again, there's a lag between the adjustment that I make and the response of the governor. Now that we're at about 60 hertz, you can see I can bump the throttle and it does move back to a set point, but can you see when I flick there, it's kind of bouncy. It doesn't really have a lot of a lot of ambition to move back where it's supposed to. But we're at about 60.5 hertz. So I'm going to start turning the gain adjustment up a little bit here. The gain is going to control how rapidly the controller reacts to a change in speed. So just bringing it up slowly. Alright, let's see what we got now. Alright, you see how much more rapidly that lever shoots up? So I'm pushing it to idle, or not to idle, to minimum position, and then it shoots right back up. Now it overshoots quite a bit, but now we're still at 60.5 hertz here. That overshoot will compensate for with stability. Okay. So you take the gain up a little bit more. Yeah, that's pretty good response there. So I'm going to push the lever to minimum, and then you can see it snap right back up. And then it snaps up, it overshoots, but it comes back down to 60. Let's see if we can improve that overshoot a little bit with stability. Stability acts to buck the function of the gain to kind of minimize that overshoot. You can see that when I over-accelerate the engine, when I push the throttle open, it snaps back pretty rapidly, as it should, and then after a second, it comes back to 60 hertz. We'll improve that a little bit more once we put the load bank on it. Remember, we don't have any load on it right now. This is just me tweaking the gain and the stability, and upsetting the throttle position. Putting it under load's a whole different story. This process can take a bit of time, depending on the application. But it's important to be patient with the thing. About 60.5 hertz there. Tweak that down a little bit closer to 60. We'll shoot for like 60.1. Let's put a little bit of load on it now, see how it responds. Put 20 kilowatt on it, about 50% load. See the throttle there? We got the gain turned up too high. Now it's hunting. So we'll tweak the gain down a little bit until the engine smooths out. It's all about finding a balance between the gain and the stability in a situation like this. The gain is the reaction of the governor, the stability is the cushioning that you could think of between the ends of that reaction that the governor, the ends of the treble that governor is reacting to. The stability acts to kind of buffer that or cushion that a little bit. Let's take another look at it. Alright, no load here. Load. No load. Load. So you can see that when it takes load, it snaps right up. It's not overshooting now. It moves to where it needs to when it doesn't overshoot. I think that was 20 kilowatt. Maybe that was 40, I can't tell. No, that was 40. It's pretty good. 60.2. I'll put a little bit more on it, get it up to flat out. There's 48 kilowatt, 60.2 hertz. Drop that off. A little overshoot to 61, but no load, 60.2. Full load drops down to, what did he say, 58.9, but then we're right back up to 60. That's not bad. Let's see if we can improve it a little bit more. A little less overshoot. That's a bit better. Yeah, so with about a 50% load, it looks like we only have maybe half a cycle of variation there. Like, it doesn't even get out of the 60 hertz cycle. Not bad. I mean, it's night and day compared to the mechanical governor. So I'm turning the stability up a little bit too far, and that's adversely affecting the response of the governor at no load. Same thing with the gain. I'll bring the gain up a little bit more. We're getting that little bit of hunting or hesitation there under no load conditions. No load. Oh, what's that? That's about 40 kilowatt. The fact that the voltage is all over the place isn't helping, but that will be corrected once we replace the voltage regulator. Alright, no load, full load. Yeah, that's good stuff right there. Boy, that's about, that's close enough to grid tie with utility right there. Yeah, so what I was looking for there was that when I lower the speed, I want to see that response, that actuator pop right back up but not overshoot. Yeah, that's pretty good. That's pretty good. We were at 60.0, we dropped to 59.0 with a full load drop on it. So that was 46 kilowatts. That's pretty good. Well, now, what do you think of that? That's pretty good governor performance right there. Alright, well, I'd consider that successful. I'm quite pleased with this performance of that governor. You know, we were holding 60 to 60.1 hertz between no load and full load. Of course, there's going to be droop. There's going to be a lag. You know, when you dump a heavy load on it, there's going to be, you know, a couple of, well, half a second or so for the thing to recover and actually get itself back to 60. Likewise, when that big load comes off, there's going to be a little bit of overshoot. But what matters is it always comes back to 60 promptly and without a lot of bouncing around either. You probably did notice this bouncing around a bit when it was under load. That's because the voltage, this voltage regulator is not doing its job. You know, we're going from like 238 to 250. That change in voltage is going to change the kilowatt load on the gen set, which in turn is going to change the engine load. And the thing was doing its job. The governor was doing its job, keeping that, you know, keeping that speed steady. So I'm pretty happy with the performance here. I'm actually going to locate this controller in this box, which originally contained a battery charger. So we'll mount the governor in there. We'll get it all wired up nice. And I think it's time to proceed to building the new control cabinet for it. We'll set up the new Basler genset controller and get all the rewiring done. I gotta do a couple things to the engine yet. It needs a coolant flush. A couple of freeze plugs on the other side are starting to rust, so I've got to pop them out, replace all the freeze plugs, and I don't know, maybe give it a paint job. So we'll keep up with it and stay tuned for the next video. So appreciate you watching and your patience through this, but we'll get it done. All right, take it easy.